Motion under gravity. Motion under gravity. For an object that is moving in space, an object that is moving in space is affected by the Earth's gravity, which is the pull or push of the Earth on an object. Is affected by Earth's gravity as well as air resistance. So when an object is in a space, like a ball thrown into the air, is subjected to Earth's gravity as well as resistance by air. So those two quantities affect the motion of the object. So whether the object will be slowed down or will move at an accelerated velocity or speed is determined by the earth gravity and the air resistance. But if air resistance is neglected, and the object is subjected only to Earth's gravity, the object will have a constant acceleration. The object will have a constant acceleration when it is falling free, when it is dropping from a particular height. And that constant acceleration, which is due to the Earth's gravity, is regarded as acceleration due to gravity. So regardless of the mass of the body, all objects falling under the influence of Earth's gravity have a constant velocity, which produce a uniform acceleration in them, which is regarded as acceleration due to gravity equals to 9.8 meter per second square, approximately 10 meter per second square. So take note, air resistance is neglected. The object is falling under the influence of Earth's gravity, is dropping, so it's going to have a constant acceleration regarded as acceleration due to gravity, regardless of the mass of the object. On Earth, the acceleration due to gravity is found to be 9.8 meter per second square. So which means even if the object is smaller or bigger, as long as it is falling under the influence of Earth's gravity, it maintains a constant acceleration of 9.8 on Earth. If you go to another planet like Moon, the acceleration of an object will reduce below 9.8. So what does this teach us? This teaches us that acceleration of an object has nothing to do with its mass. The mass of an object does not affect its acceleration if the object is in space, does not affect its acceleration. So equation of motion under gravity, we have 1, V is equal to U plus or minus GT. Remember, for linear motion, we have V is equal to U plus AT. But this time around, we have plus or minus. Number 2 is V square is equal to U square plus or minus 2GH. The third one is H is equal to UT plus or minus RGT square. RGT square. So when do we make use of plus? When do we make use of negative? So meaning as we have it here, equation 1, 2, 3 can be split into 6. V is equal to U plus GT, that's 1. V is equal to U minus GT. V squared is equal to U squared plus 2GH. V squared is equal to U squared minus 2GH. H is equal to UT plus half GT squared. H is equal to UT minus half GT squared. So these three equations can be split into 6. I will take number 1 for instance. V equals to U plus or minus GT can be written as V equals to U plus GT. We can write it as V is equal to U minus GT. So for an object that is dropping from a particular height, if an object is dropping from a particular height, that means it is falling under gravity. In that instance, we make use of equation 1. For an object that is dropping from a particular height, the acceleration will increase under gravity. But for an object that is thrown upward, the object is moving up against gravity. Since it is moving up against gravity, the Earth's gravity will be contrary to the motion of the object. As a result, the object will be slowed down. The object will begin to decelerate until it gets to a particular height, which is regarded as maximum height, that the object will not be able to ascend further. So at that point, the velocity of the object will have been exhausted, will have turned to 0. So for an object that is thrown upward, that is ascending upward, the object will be decelerating from its initial velocity. So you make use of equation 2 here, the negative 1, which says V is equal to U minus GT. The same applies to equation 2 and 3. For object that is ascending, use negative value. For object that is descending, dropping, you use positive value to determine the quantities of the object. Vertical projection. Vertical projection. This is an object. This is the ground floor. So the object is projected upward, and then we attain a particular height, which we call maximum height. As the object is projected upward, it was projected with initial velocity u. The initial velocity will begin to decrease until the object attains a maximum height. The final velocity of the object at maximum height will be 0 meter per second. Immediately the object begins to drop again, the velocity will change. It will increase. So it will increase here, while here the velocity was decreasing. So for this object that is projected upward, we have to determine the time taken to reach maximum height. Time taken to reach maximum height by the object to reach maximum height. So we are going to use V is equal to U minus GT. V is equal to U minus GT. Okay. So If we make use of v is equal to u minus gt, where v is equal to 0 meter per seconds, that means 0 is equal to u minus gt. Bring gt to this side. That will give us 0 plus gt equals to u. Gt is equal to u. So make u the subject of formula. Make u the subject of formula. So we make u the subject of formula. Rather, we want to find t. Make t. It is t you are to make the subject of formula. Make t the subject of formula. So your t will be initial velocity all over g. Your time taken in seconds is going to be initial velocity all over acceleration due to gravity. So if you want to find the time taken for an object that is projected vertically, the time taken to reach the maximum height is determined by the initial velocity divided by acceleration due to gravity. If we are to determine the time of flight of the object, the time of flight is the time taken by the object to remain in air. The time taken by the object to remain in air. That is, the time taken by the object to ascend and to descend. That is, the time taken for the object to go to and back, to and fro. That's the time of flight of the object in the space. So that's going to be twice the time taken by the object to reach the maximum height. The time of flight is represented by capital T, while the time taken for the object to reach maximum height is represented by small letter t. Both have the same SI unit, which is seconds. So time of flight is the time taken by the objects to travel to and fro in the air, in the space. So the time taken for it to go vertical and downwards, and that time is going to be 2 times the time taken for maximum height, where small t is u over g. Then time of flight, which is capital T, which is also regarded as the period, is going to be 2u all over g. 2u all over g. Don't forget that the SI unit is also seconds. Maximum height attained. Maximum height attained by the object. Don't forget that the maximum height, the final velocity of the object is 0. It will reach 0 before it will not turn again when the object is dropping. So at maximum height h, v is equal to 0 meter per seconds. We have u and we have u and g. Then if we make use of h is equal to, let's make use of v square. v square is equal to u square minus 2gh. We make use of minus because the object is ascending. So 0 square equals to u square minus 2gh. Bring minus 2gh to this side. Now give us 2gh is equal to u square. So make h the subject of formula. Make h the subject of formula. H will be equals to u square all over 2g. The SI unit for h is in meter because it is a distance. So to determine the maximum height of an object that is projected upward, that is ascending, you make use of h equals to u square plus all over 2gh. Before us is an example on the topic to consider. A tennis ball is thrown upwards from the ground with a velocity of 50 meters per second. So you are given your initial velocity, which is u, as 50 meters per second. And you have to calculate the maximum height reached. So which means, since the object is projected upward, it is under acceleration due to gravity. G is going to be 10 meters per second square. So you have to find the maximum height. Maximum height h. H is equals to what? U square all over 2g. So that's going to be 50 square all over 20 times 10. That's 2,500 divided by 20. That will give us what? That will give us 125 meter. Cross check with your calculator. 125 meter. Okay, I think that is ascertained. You have to determine the time to reach maximum height. Time to reach maximum height. The time to reach maximum height is determined by T is equal to U all over G. And your U is 50, your G is 10. So the time to reach maximum height is 5 seconds. 5 seconds. So it takes the object 5 seconds to reach maximum height. So now that we have to determine the time of flight. Time of flight is 2 times time taken to reach maximum height. Time of flight is equal to 2t. That's 2 times 5. And that's 10 seconds. That is 10 seconds. Alright. Till I come your way some other time, I say keep studying, keep learning. Bye for now.